Hello folks, again a beautiful question for you from another board, but very useful, as I always stress. It says that three identical resistors are connected in series across a cell. So that means that if we have a cell here, we have got three resistors in series, somewhat like this. The same three resistors, it means that their resistance value is same, R, and let me say the EMF is E. Assume that the cell has zero internal resistance and does not run down during the experiment. That means the EMF will not decrease. Sorry, I've skipped the second sentence actually. The same three resistors are then connected in parallel across the same cell. So that means now we have to connect them parallelly. So in order to save space, I'm doing like this. So we have the same resistors in parallel, 1, 2, and then another 3. So connections like this. So they are in parallel, R like this, and this is E. Now what is the value of the ratio power from cell with resistance parallel? So here, so let me say this is the parallel arrangement, and this is the series. Let me write here series. So we have to find the ratio of the power from cell with resistors in parallel here, the power in this case and the power in this case. Let's first remember that. Let's find the I here. So let us say this is IS. S stands for series. The value of IS should be equal to E divided by the sum of all the resistors. So it is 3 and R. IS equal to E by 3R. And the value of I here will be equal to, so let us say it is IP. This will be equal to E divided by the combined value of these resistors will be equal to R by 3. Sorry, let me say IP is equal to E by R by 3. So it becomes 3E by R. That means the overall current here is high, and in this case it is less. Now the power from cell should be equal to, so power S should be equal to it is E into IS, so it's equal to E into E by 3R, which will be E square by 3R. And the power in case of primary will be equal to, again, E into I parallel, that's equal to E into 3E by R, equal to 3E square by R. Now the ratio will be equal to, so this is equal to power parallel by power series, that's equal to power parallel is 3E square by R divided power series is E square by 3R. So this cancel out, so 3 goes here. It is 3 into 3, and that's equal to 9, or I can say it as 9:1. So the answer choice corresponding to this is choice number D. So choice number D should be the correct answer. So what we have done here is we have series connection, parallel connection. We found the current here. The current here is E divided by the total resistance here, which is 3R. The current here is E divided by the total resistance, which is R by 3, so it's equal to 3E by R. So power series E into I, one of the formula. Power parallel E into I, yes, P. So it gives this, and the ratio gives 9:1, giving choice D the correct answer.